Welcome back to the channel. Today, we're inside a real soap manufacturing factory to explore how Safeguard soap is made.
Inside facilities like this, millions of soap bars are produced every single day.
The foundation of soap begins with carefully sourced fatty materials. Their quality determines everything that follows. The foundation of soap begins with carefully sourced fatty materials. Their quality determines everything that follows.
Refined fatty acids form the structural backbone of each bar. But before transformation begins, they must be precisely measured.
Liquid additives are stored separately under controlled conditions. Their role will become important later in the process. Liquid additives are stored separately under controlled conditions. Their role will become important later in the process.
Purified water acts as a critical carrier. It ensures uniform blending during early preparation stages. An alkaline solution is essential for saponification. But before that reaction can happen, conditions must be stabilized.
Temperature and pressure are monitored continuously. Stability at this stage prevents defects later on. Temperature and pressure are monitored continuously. Stability at this stage prevents defects later on. Raw materials are introduced in a strict sequence. Timing here is critical. Raw materials are introduced in a strict sequence. Timing here is critical.
Heat begins softening the solid feedstock. The mixture slowly transitions toward a workable state. Heat begins softening the solid feedstock. The mixture slowly transitions toward a workable state. Early samples are taken for baseline analysis. Quality control begins long before the soap is formed. Early samples are taken for baseline analysis. Quality control begins long before the soap is formed. Chemical purity is verified through precise testing. This ensures the reaction will behave predictably. Once approved, the system transitions into active preparation. The pace of production begins to build. Once approved, the system transitions into active preparation. The pace of production begins to build. Materials now move toward the main blending unit. Each transfer is calculated and controlled. Heat rises steadily toward reaction threshold. The chemistry is nearly ready to begin. Heat rises steadily toward reaction threshold. The chemistry is nearly ready to begin. Supervisors monitor every parameter from above. Oversight ensures nothing is left to chance. The mixture begins to transform under heat and motion. This is only the beginning of saponification. Molecular bonds are rearranging at this moment. But the reaction must continue to completion. The partially reacted soap mass is released from the reactor. It now moves into the initial processing stage for stabilization. A heavy-duty screw conveyor moves the material forward. Controlled transport prevents premature cooling.
Temperature remains tightly regulated during transfer. Consistency at this point determines final texture.
The crutcher mixer further homogenizes the soap base. This step eliminates uneven density. Mechanical agitation redistributes moisture and alkalinity. Uniform blending is essential before drying.
Additional conditioning agents are introduced in controlled amounts. Precise dosing prevents imbalance in the formulation.
Fragrance components are blended while the mass remains fluid. Even distribution ensures a consistent scent profile.
Viscosity is measured in real time. The mixture must reach an exact thickness before the next phase. The blended soap now enters the drying tower. Moisture reduction begins here. Inside the tower, the mixture is atomized into fine droplets. Hot air rapidly removes excess water. As moisture evaporates, solid soap particles form. These granules are known as soap noodles.
Samples are tested for moisture balance. The drying process must meet strict parameters.
Residual water levels are measured precisely. Too much moisture can weaken the final bar.
Once verified, the noodles move to temporary storage. This stabilizes the material before refining.
The next phase begins with controlled feeding. Preparation for mechanical refinement is underway. Mechanical force breaks down irregular shapes. This improves structural consistency.
Rolling compacts the material into uniform sheets. Density increases with each pass. Each refining stage reduces air pockets. Smoothness and cohesion are gradually achieved.
The texture is now consistent and pliable. It is nearly ready for shaping.
The continuous sheet is divided into workable sections. Controlled cutting ensures equal mass.
Flexibility indicates proper moisture balance. This confirms readiness for extrusion.
The refined soap now enters the extrusion system. In the next stage, this material will be shaped into continuous bars ready for forming.
The core manufacturing stage begins inside the vacuum plotter. Here, pressure and vacuum combine to densify the soap mass.
The rotating screws compress the material continuously. Air is removed to improve structural strength.
A vacuum system extracts residual air. This step prevents cracks in the finished bars.
The compressed soap exits through a shaping die. It now forms a continuous solid column. Dimensions are monitored instantly. Uniformity is critical at this stage. Laser sensors verify exact thickness. Even minor variations are corrected immediately.
The continuous column is divided into individual blanks. Each block carries identical mass and density.
The soap remains warm and pliable. Temperature control ensures smooth shaping ahead. The blanks lengths now approach the stamping unit. Mechanical precision defines the final form. Hardened steel dies shape each bar. Pressure ensures crisp edges and uniform contours. Hardened steel dies shape each bar. Pressure ensures crisp edges and uniform contours. High compression removes imperfections. The bar takes its recognizable shape. Each bar emerges identical to the last. Automation guarantees consistency at scale.
Several lines run at once to meet demand. Scale is central to industrial soap production.
Excess material is collected and reused. Nothing in the process goes to waste. Recovered material re-enters the cycle. Efficiency is built into the system. Cooling stabilizes the bar's structure. Controlled airflow prevents surface cracking.
Air circulation balances internal moisture. The bars gradually firm to optimal hardness.
Surface temperature is checked continuously. Proper cooling ensures dimensional stability.
Robotic systems correct alignment instantly. Automation maintains uninterrupted flow.
Separate streams combine into unified output. The process remains seamless and coordinated.
The surface now appears dense and refined. Structural integrity has been achieved.
Human oversight complements automation. Physical inspection confirms mechanical accuracy.
Powerful drive systems sustain continuous production. Precision engineering keeps every component synchronized.
The bars have now completed core shaping. Refinement and detailing await in the next phase.
Above this. From compressed mass to fully formed bar, Transformation is complete. Next, precision refinement. After core shaping, each bar moves into precision refinement. Alignment is the first step toward exact finishing.
Automated guides correct minor deviations. Even a millimeter of error is unacceptable at this stage. Surface polishing smooths microscopic imperfections. This improves both appearance and feel.
Dust extraction maintains a clean working environment. Air quality is carefully controlled.
Edges are refined for symmetry. The goal is uniform geometry across every unit.
The contour must be sharp, yet smooth. Consistency defines industrial quality.
Optical systems scan every surface. Imperfections are detected instantly.
Software compares each bar to calibrated standards. Deviations trigger immediate review. Non-conforming units are automatically removed. This protects overall batch integrity.
Human inspection adds another layer of control. Tactile checks confirm machine accuracy.
Dimensional tolerances are measured precisely. Uniform thickness ensures predictable performance. Humidity stabilization prevents cracking. The internal structure continues to balance.
Airflow distributes moisture evenly. Stability at this stage prevents warping later.
Hardness is tested under controlled pressure. Each bar must meet mechanical standards. Conveyor speed is fine-tuned continuously. Precise spacing prepares the bars for final refinement. Alignment verification ensures accurate marking. Precision prevents misplacement during stamping. Final surface detailing enhances clarity. Controlled force preserves structural density.
Approved units receive traceable batch coding. This ensures full production transparency.
Laser guidance confirms geometric accuracy. Every bar remains perfectly centered. Gentle warming enhances surface finish. The texture becomes smooth and uniform. Only bars that pass every test move forward. Standards are applied without exception. Stability is engineered into the conveyor system. Even minor vibration can affect uniformity. The bars now meet strict dimensional and visual standards. Their structure is consistent from edge to edge. With verification complete, the pace increases. The final stage approaches. Precision refinement is now complete. The bars are ready for final inspection and packaging.
Every detail has been measured, adjusted, and confirmed. The next stage will focus on final approval and preparation for distribution. Before packaging begins, every batch undergoes strict quality control. Verification ensures consistency across millions of units. Each bar is weighed individually. Exact mass confirms proper formulation and trimming. Each bar is weighed individually. Exact mass confirms proper formulation and trimming. Any deviation from target weight is removed immediately. Tolerance margins are extremely narrow.
The structural strength is tested under pressure. The bar must resist deformation within defined limits. Applied force is measured precisely. These readings verify mechanical durability.
Performance testing evaluates lather quality. Foam structure reflects chemical balance.
The density of foam indicates proper saponification. Uniform bubbles suggest even formulation.
pH levels are carefully verified. Balanced alkalinity ensures skin compatibility.
Electronic meters confirm chemical stability. Accuracy here protects consumer safety. Sample bars are observed under controlled conditions. Stability over time is essential.
Environmental data is logged continuously. Long-term consistency must be guaranteed.
Internal structure is examined visually. Uniform density confirms proper vacuum processing. Absence of air pockets indicates strong compression. The core must be as refined as the surface.
Micro-level inspection detects surface flaws. Precision optics enhance quality control.
Abrasion tests evaluate surface durability. The bar must withstand daily handling.
Data analytics support physical testing. Statistical consistency confirms process control.
Approved units receive traceable batch coding. This ensures full production transparency.
Metal detection safeguards against contamination. Even microscopic fragments are identified.
Any anomaly triggers immediate review. Production resumes only after confirmation.
Only bars that pass every test move forward. Standards are applied without exception.
Final approval is documented physically and digitally. Accountability remains central to the process.
With verification complete, the pace increases. The final stage approaches. Every bar reflects uniform craftsmanship. Consistency defines industrial excellence.
Rigorous inspection ensures reliability and safety. Next, the finished bars will be wrapped and prepared for distribution.
The molded bars now move toward their final stage. Each piece carries the precise shape formed moments earlier in the process.
Automated guides ensure perfect spacing. Even millimeters matter at this scale of production.
Production now reaches full synchronization. Thousands of bars move forward in steady rhythm. Protective wrapping begins automatically. The film is measured and cut with exact timing. Each bar is sealed with precision. The wrapping protects both quality and hygiene. The sealed bars move immediately to inspection. Protection alone is not enough without verification.
Cameras examine every surface. Imperfections are detected in milliseconds.
Any flawed unit is removed instantly. Consistency remains the priority.
Approved bars continue forward. The final packaging stage now begins.
Cartons are formed automatically. Every fold is aligned to exact dimensions.
Each bar is inserted careful. Speed never replaces accuracy.
Cartons are sealed securely. Structural integrity protects the product in transit. Final weight verification confirms consistency. Even small deviations are flagged.
Cartons are stacked with mechanical precision. Automation ensures stability and speed.
Every layer follows a calculated pattern. Balance prevents damage during transport.
Human oversight remains essential. Technology works alongside trained experience.
The pallet is sealed for shipment. Protection extends beyond the individual bar.
Heat bonds the wrapping firmly in place. Stability is reinforced for long-distance travel. The finished shipment is now mobile. Distribution becomes the final link in the chain.
Thousands of bars await dispatch. Each represents a completed cycle of manufacturing. The factory connects to the outside world. Production now transitions to distribution.
Shipments are arranged for safe transit. Efficiency continues beyond the factory floor.
The journey begins beyond these doors. The manufacturing phase is complete.
From raw materials to finished bars, The transformation is complete, precision-guided every stage.
What began as simple ingredients has become a finished, essential product. The process now continues wherever the bars are used.